Every single second of every day, whether you're inside or outside, you are being showered by this invisible rain. And no, it's not water. It's something way more exotic, something that's traveled from the most violent events in the entire universe, passing right through you and your devices. Today, we're talking about cosmic radiation.
So, to get us started, here's a little puzzle for you. What could a star exploding millions of light years away possibly have in common with the laptop or the phone you might be watching this on right now? Well, stick around, because the answer is actually a pretty fascinating look into the hidden forces that connect us to the cosmos.
Okay, so let's just dive right in at the beginning. What exactly is this stuff that's constantly bombarding our planet?
Right. So the first and most important thing to get is that this isn't like sunlight or X-rays, which are forms of light. No, cosmic radiation is made of actual physical particles. Think of them like tiny subatomic bullets, basically just atomic nuclei that have been stripped of their electrons and are flying through space at nearly the speed of light.
So what are these little cosmic bullets made of? Well, if you look at the breakdown, the vast majority, we're talking about 90%, are just simple protons, the nucleus of a hydrogen atom. Then another 9% or so are alpha particles, which are really just helium nuclei. And that last tiny little 1%, that's a super interesting mix of all the heavier elements, everything from carbon all the way up to iron. Now, this is a really important distinction to make. We talk about primary radiation. That's the original particle that makes the incredible journey from a distant star. But then you've got secondary radiation. This happens when that primary particle smashes into an atom in our upper atmosphere, creating a whole shower of new, different particles. What we actually experience down here on the ground is almost entirely this secondary type.
Okay, so if these particles are the messengers, where are the messages being sent from? To find that out, we have to look at some of the most powerful and violent engines in the entire cosmos. And this image just brilliantly captures the insane scale we're talking about here. The journey of a single cosmic ray begins in an environment of almost unbelievable violence and energy. We're talking about the shock wave from a supernova, or the chaotic, swirling disk of matter being torn apart around a supermassive black hole.
We can basically sort these sources into three main buckets. First, you've got solar cosmic rays, which come from our own sun. They're a bit lower in energy, and they kind of come and go with things like solar flares. Then there are galactic cosmic rays from right here inside our Milky Way. Think supernovas. These guys are much higher energy, and they form a sort of constant background hum. And finally, you have the most powerful of all, extragalactic rays, coming from other galaxies and carrying energies we literally can't replicate here on Earth.
So imagine this tiny particle. It's traveled for millions of years across the empty void of space. But now, as it finally arrives at Earth, its journey isn't over. It's about to encounter a series of incredibly powerful defense systems. So our first line of defense is the planet's magnetic field. It acts just like a sci-fi force field. It grabs onto these electrically charged particles and just deflects a whole bunch of them away from the planet. And you can see how this protection is weakest at the poles, which is exactly why the beautiful auroras happen there. But some of the highest energy particles, they just punch right through that magnetic field. And when they finally hit an air molecule, bam! It's like a subatomic explosion. That single primary particle shatters, creating this incredible cascade, a shower of literally millions of secondary particles that rain down through the atmosphere. So how good of a shield is our atmosphere? Well, it's actually incredibly effective. The air above your head right now provides the same amount of radiation shielding as being under about 10 meters or 33 feet of solid water. It absorbs something like 99% of the initial cosmic radiation. It's amazing. And the big takeaway from all this is, well, it's pretty profound. These two shields, the totally invisible magnetic field and the seemingly empty air above us, are the only reasons that complex life like us can even exist on the surface of our planet. Without them, the constant cosmic bombardment would be absolutely lethal. But, despite our planet's really impressive defenses, they're not perfect. Some radiation does get through, and those secondary particles that make it all the way to the surface can have very real consequences, both for our bodies and for our technology. So when one of these high-energy secondary particles flies through your body, it acts like a tiny little bullet. It can actually knock electrons off the atoms it passes. That's called ionization. Now, if that happens to an atom inside your DNA, it can cause the strand to break, which can potentially lead to a mutation. Over a lifetime, this constant background radiation just slightly increases our risk for things like cancer. And this right here brings us back to that first question about your laptop. See, that exact same ionization process can happen inside a microchip.
A single particle can strike a memory cell and flip a bit from a 0 to a 1, or the other way around. It's called a bit flip. Now, it's pretty rare, but it can cause these totally random computer errors, a little digital ghost in the machine, created by an exploding star millions of light years away.
Okay, so let's connect the dots here. Where on Earth are you most exposed? Well, you have less atmospheric shielding the higher up you go, and you have less magnetic shielding the closer you are to the poles. So, it makes sense that airline crews, and even frequent flyers, especially those on long-haul flights over the poles, end up receiving a significantly higher dose of cosmic radiation than people on the ground.
But here's the thing, cosmic rays aren't just a hazard. For scientists, they are a priceless resource. By studying these particles, we are essentially reading mail that's been sent from the farthest corners of the universe. This whole life cycle is just packed with clues. We can see how a particle gets born in some distant, violent event, how it travels across intergalactic space, how it gets bent by magnetic fields, and how it finally arrives at Earth. And down here, our detectors can intercept that resulting air shower and actually decode the particle's original properties. We can read the message it carried all that way.
And what are these cosmic messengers telling us? Well, for one, they carry direct information about the supernovas or black holes that created them. The way their paths get bent tells us about the magnetic fields they pass through in deep space. Some scientists are even looking for signatures of dark matter in the data. But maybe coolest of all, they arrive with energies far beyond anything we can create in our biggest particle accelerators, giving us a free window into the world of extreme physics. And here is a truly mind-bending idea to chew on. Remember how we said cosmic rays can cause DNA mutations? Well, some scientists think that over billions of years, this constant, low-level source of genetic change might have actually been one of the engines of evolution, a cosmic force helping to drive the amazing diversity of life on our planet.
So in the end, this invisible rain from the stars isn't just some weird curiosity or a hazard. It is a fundamental part of our universe that has probably shaped our planet, our technology, and maybe even our own biology. Which leaves us with one last thought. If this cosmic radiation helped shape our past, how is it going to shape our future?